Okay, I think we can roll it. And we are moving now to debugging HTTP 3 upload speed in Firefox, and I'm more than happy to welcome Manuel Bucher for it.
Hello, I'm Manuel. I'm working at Mozilla in the networking team called NECO, and we work on Firefox networking. And in this talk, I'm going about our debugging of HTTP3 and HTTP2 upload speed. And for this, I'm going to give you some background information first. Then I'll cover the HTTP2 upload speed problem that we investigated last year. And afterwards, I'll go over to the HTTP3 upload speed problem that we investigated afterwards. So, first to the NECO team. We, in general, focus on security, privacy, but always also on performance. And our protocols that we work on is mostly HTTP, but also DNS, WebSocket, web transport. Yeah. And we also own the caching and the proxy feature. So this is what we in general work on. And when we think about networking performance, we usually think about it in terms of how long does it take from clicking a link to seeing the result. And for this, we usually just need download speed. For other use cases, like uploading large files, like videos, we generally also need the upload speed. In this talk, I'm going about the HTTP2 and HTTP3 upload speed. Those protocols are more in focus. They are relatively newer than the HTTP1. They got introduced in the past decade. And so for HTTP2 upload, first, what's the difference in HTTP2 to HTTP1? In HTTP2, we allow to make more multiple HTTP requests via one TCP socket. And this TCP socket is handled by the operating system. And real quick, the bug in our HTTP code that caused the slow upload was that we configured the socket to have a fixed size buffer of 128 kilobytes. And this fixed size buffer became a bottleneck in high bandwidth situations. For the fix, we just needed to adjust this TCP socket to not set the fixed size buffer and let the operating system handle the buffer size. And this shows that the operating system is responsible for the upload speed or the performance of upload. And this is a stark difference to HTTP3 upload. And with this fix of just not setting the fixed size buffer, we can take a look at Chrome upload speed, Firefox before the fix in red, and in yellow Firefox after the fix. And we see that in certain configurations like high bandwidth and also from low to higher round trip times, we have upload speed improvements up to like 4 times the speed. So we only have to wait a fourth of the time, and we are on par here with Chrome, which is using like all the bandwidth you can use for the upload. With this fixed last year. We took a more in-depth look at upload speed in general, and we also had like bug reports about slow HTTP3 upload, and with HTTP2 seeing very good results, we made it a high priority for us as well, and took a look there. So for the fix, or seeing how much it changed, we introduced some high-level telemetry, and these are percentiles of user-reported upload speed, and we have different versions. 114 on the left side is around 1 year ago, and in 115 to 16 we rolled out the HTTP2 upload speed fix, and we can see the improvements in the like high-level telemetry about upload speed. It's an improvement like in the higher parts, it roughly doubled, and not quite, but yeah, it's very visible. So now to difference to HTTP3 upload. HTTP3 upload is widely different. HTTP3 uses a different transport layer. We don't use TCP anymore, but QUIC was standardized alongside with HTTP3, and just relatively recently. So the standardization was finalized in 2021, which is 2 to 3 years from now, right now. And Firefox also included HTTP3 upload around the time in 2021. The work started in 2019, which is all relatively recent in comparison to TCP and HTTP2. HTTP2 is around a decade now old. And the problem is different here because the operating system is responsible for the TCP stack. It is responsible for sending all the data performantly, and in QUIC we have to implement the same congestion control in Firefox, in the Firefox application, so it's not the responsibility shifted to Firefox or the application. Yeah, TCP is already decades old, what got standardized 50 years ago, and is in operating systems since like 30 years, and got like a lot of eyes on it. And our Firefox implementation is really new, and we were kind of the first ones to look into upload speed performance here, so we had a lot of low-hanging fruits here to work on. And I wanted to visualize this a bit, like we have HTTP2 and HTTP3, which are very similar. In HTTP3, we rely on QUIC, and QUIC is also implemented by us. In HTTP2, we have TCP, and TCP is provided by the operating system. Yeah. So I want to go into a few findings that we had in our presentation, or in our I/O graphs and other tooling that we took. The most useful tool for us was I/O graphs, with where we just printed within the application, like with logging, when we send packets, when we receive packets, how big our congestion is, and everything. So the first problem we have, or what does this graph show? So this graph is our congestion window over time. What is the congestion window? So the congestion, well, I would like to go over this. We don't want to overload the network. And overloading the network is called like congestion control, or not overloading the network. And this is the responsible of the transport layer, which is TCP or QUIC. And all the bugs that we had were in this congestion control, or most of the bugs. And the congestion window that we have is like the estimate of how fast we can upload right now. And this changes over time. With every packet that we receive, we think we can upload more. So we have a graph like here where we steadily increase the congestion window over time with all the packets that we receive. And when we detect that packets got lost, we are assuming that the network is overloaded, and we reduce the congestion window by half. And this is like one of the early graphs that we had, and orange are like the bytes in flight that we have. They circulate from top to bottom, increasing again. Blue is the congestion window, and what we see at the drop points is that the congestion window doesn't halve. We would expect it to halve during a congestion event. Instead, it drops almost to zero. And this was one of the bugs that we had. We just dropped to zero, or each packet that we detected as lost half the congestion window, and normally you would only do this once, but we did it multiple times for each packet. So essentially, we drop to almost zero on all congestion events here. This was one of the first fixes. Later, later, when this is the same graph, with the congestion window problem fixed, we had to investigate further because there were more problems. Here, like all these drops of packets going down, we want to stay with our bytes in flight as high as possible, with our upload speed as high as possible, but we dropped down quite some times. And if we for this problem, we need a bit of background information. And this background information was this slide, which I apparently put a bit later. And I'll go back to the background about QUIC first before going over the next problem. So QUIC got introduced. Sorry about the mix-up here. QUIC, the new transport layer protocol. What is QUIC? QUIC is on the same layer as TCP, but conceptually you can have multiple TCP connections at once over one QUIC connection. And we have other benefits like TLS being integrated, so that the connection setup phase takes less time, only one round-trip time instead of like 2 round-trip times. Yeah, and now we get back to the introduction of the concept of congestion control. Congestion control is for for us handles like not overloading the network from all participants in the internet. So everyone makes sure that we don't overload the network and keep it usable for everyone. And the congestion window is one of the constants that we looked at the first graph and also in the second graph. This is our estimation at how much can we upload at a time. Like what is our upload speed to the destination server? And so our estimation depends on us receiving packets. And we want to increase the congestion window only if we are like sure that we are using the congestion window. Like we are sending as much data as we have in the congestion window, because otherwise we are not sure if our estimate is like correct, if we are sending like less data than what is that we estimate we could. And this detection on whether a packet was sent during like the utilization of the congestion window, like sending as much data as we could. This was had a bug as well and made us mark packets as not not utilizing the congestion window for 50 to 75% of the packets, which meant that we didn't increase the congestion window as fast as we could. This is another like simple incremental fix for our HTTP3 upload speed problem. And when after fixing this, the graph looks like this. It has a like steeper curve, like a steeper line, and yeah. Here we also see that the first problem that we had got fixed. We don't drop to 0 with the congestion window, but have it halfway here. With these steady increases, we can also see them in our high-level telemetry that we introduced for our HTTP2 upload speed problem. And in HTTP3, in the higher network bandwidths, we have like already an increase of like 3 times. We are 3 times as fast as before tackling the problem, from around 31 megabits per second to 93 megabits per second. This is the like 95 percentile. So this is network speed of better than 95 of all clients. Yeah. So also visible from the high-level telemetry. And for the current state, we are still working on this. We have more bugs that we are aware of, and are also in contact with, or in collaboration with contributors who can upload, or we requested logs from them to have a look at their network condition. And this is like the diagrams from before, but from like the contributors log, where we can identify which problems are present from like our machines in comparison to their network location. And with the logging mechanism, which we also included in Firefox, so this became a bit easier about logging. And a few of the further works that we are currently still aware of is that the upload has a few CPU bottlenecks, like and mostly profiling. The QUIC stack made us aware, like not the cryptography part of QUIC is taking most of the time, but some other parts, which is unexpected. And we have already identified a few code paths that can be improved and are improving these, and will also continue with profiling this. We also have, similar to the HTTP case, we have a fixed size buffer. This will get to be a problem at some point at much higher bandwidth than with the HTTP2 upload speed problem, because we have like a buffer that is 8 times as high, 1 megabyte instead of 128 kilobyte. And we are also aware of the problem that when we are in packet reordering networks, we detect these packet reorderings as losses like too frequently. And there are ways around this in TCP specifications, like reg or forward egg, that we are taking a look and investigating which one we want to implement and which proves to be the best of the options here. We are also setting up CIs to catch regressions in the future, and also have like a detailed view from different networking conditions, how they look. And yeah, we have seen like very good improvements in HTTP3 already. It's now at a similar level to the HTTP2 upload. So it's looking already a lot better, but we are still on it, and we are aware of a few bugs, and we will investigate further, and we want to make it as good as we can to see all the benefits that HTTP3 can provide for us. And a lot of this was like in cooperation with contributors reporting bugs, and one specific bug is the HTTP3 upload speed bug. If you want to take a look at our work there, you can follow the investigations there. You can reach us at the Matrix channel if you want to get in contact with the NECO team. We have NECO-specific documentation also about creating logs. Yeah, if you're interested in the NECO team, we are making ourselves a bit more transparent by providing our meeting notes and having a blog. And if you need help with fixing bugs or want to get in contact, like contributing, we also are going to provide office hours where you can talk to us directly and get in touch. So thanks for listening.
Thank you, Anna. We might have time for 1-2 questions. So where am I? Oh, cool. Oh. So it's fast one.
Hi, thanks for the talk. Just wanted to ask if there's any chance of QUIC being brought into the Linux kernel or Windows kernel or wherever else Firefox runs.
So the question is whether QUIC is going to be implemented in the operating system with socket APIs. So I'm expecting that it will be implemented at some point. We do have, I've seen like some TLS integration. This is one of the stoppers probably, that TLS has to be integrated into the kernel as well. QUIC is so new that it didn't have time to be really integrated into the operating system, and I think as soon as operating systems provide APIs, we will start using them. Yeah, they are not here right now, but in the future, I would assume yes. But like 2 years of being standardized is like nothing. Yeah, TCP is like for 30 years already.
Yeah. Last question, as I see a lot of people coming in, and for sure Manuel will be available outside, no?
Yes.
I'm making promises in your name.
My question is just which congestion control did you implement in Firefox?
Yes, we are using QUIC by default. We have also implemented New Reno, and we are looking also at BBR because this is also exciting, or like is better for lower latencies. We didn't have a plan to implement it right now, but it's like in the future we probably will tackle that too.
Thank you so much, Manuel. I didn't count some of them, but I took photos and we can count at each one later. Yeah. Frida, I saw the sticker you have on your water bottle. Yalazilla, Yazilla.
Yalla.
Yalazilla, Yalazilla. And I think also this is, no? It's traditional.
Yeah.
Yes. You're stuck with me for 2 minutes or so. Karma needs another adapter and we are looking over it. It's coming. We're fixing everything. Is anyone that already got the t-shirt from the booth or the collapsible mug? Oh, good. You're saving the world, us too. I'm there for it. I also like it. Ooh. Someone else is doing steps today. This is how you stay in shape. You moderate the dev room, you run, all good. We are fast. Also, big thank you to Konstantina. She organized the booth, by the way. Konstantina and Mozilla, if you want to... Yes, do you want to? She brought more stickers here, with especially this talk is related to MDN. We have the sticker here, if you want. And we have the cute llama. I heard it. Gold. It's here, waiting. One is mine. And if you want to learn more about llama, the project, not the animal, we have a guide here with all things related to Mozilla and AI. Grab them after. And the first one is from the first talk about support. Grab these papers, and you can have more information. Are we ready? Oh, let me go then. Without further ado, ladies and gentlemen, Chris will gonna introduce us to the MDN curriculum.
Hi. So, hello everyone. Nice to see you all. Thanks for coming. My name's Chris Mills, and I'm going to take you through a new MDN project soon to be released called the MDN curriculum. Take you through a little bit about who I am to begin with. I describe myself as a death metal hippie. I love documentation, and I love the open web, and I love tinkering with open standards. I used to work for Mozilla for quite a while. I was the content lead and team manager for MDN. but I left and did some other stuff, and now I've come back as a contractor, and this is the current thing that I've been working on with the MDN team. Another thing to add is that I'm a heavy metal drummer, so if you want to ask me a question later on, please speak slowly. A little bit about this talk. We are going to talk about, first of all, some of the problems that myself and others perceive with front-end development in 2024, particularly in terms of education and the skills that new web developers are bringing to the table when they come and get jobs. We're also going to take you through the thoughts of how a new curriculum could solve some of these problems, and some of the research that we did to try and prove out some of our theories about this. I'll then talk to you a little bit about the actual curriculum that we came up with and kind of its structure, its approach, some of its goals, and then I'll talk to you about possible next steps, some of the things that we can then go on to do with this curriculum as a basis. Now, first of all, I'm going to talk to you about something that we're very good at in open source communities, problems and complaining. Yay, Mr. Brexit's back in the UK government. I'm so pleased. No, not those kind of problems. Really, we're talking about problems with front-end development, kind of what skills are new web developers missing when they come into the industry? What's the effect of what's the state of web education? What kind of effects are these problems having on, the web in general and the quality of sites that we build? One thing that I've talked to quite a lot of hiring managers about, and this will also be mentioned in the research that I'll talk about later, is just lack of general core principles of new developers coming into the industry. I mean, a short anecdote that I'll share with you is a couple of years ago, a friend of mine called me into his company. He worked for a large agency at the time, and he wanted me to talk to all of his front-end teams about accessibility. Really basic accessibility, just kind of use headings and paragraphs and use alt text, that kind of stuff. And I went in there and did a 20-minute talk, and I was thinking, do I really need to talk to these folks about this? And it was like a revelation to them. They were all like, whoa, so that's why you have to do this stuff? I was just blown away. I was like, I thought we'd kind of largely won this battle and moved on. It kind of blew my mind about how little they knew about this stuff. And I kind of feel that with a lot of the new developers coming into the industry, they're not really learning core languages and old school standards as much as just kind of, well, I want to get a job, so I'm going to learn React, and I'm not going to turn this into a massive whinge, but that kind of results in not knowing these core principles and best practices quite as well as perhaps they could. The next thing to talk about is lack of core language skills. This is another thing that hiring managers have talked to me about a lot. So people learn React and other frameworks, but they don't maybe take the time to learn the core JavaScript language as much as they could. So, they can build websites that work great and have good-looking UIs, but maybe their problem-solving skills aren't quite as good as they could be when they suddenly need to get brought onto a problem that requires not writing some code inside a framework. And also, we kind of worry that maybe this is not so good for people's long-term employability, because, if they've just learnt React, what then happens if all of a sudden the company goes, well, now we're going to do all of this stuff in a different framework, or, another framework suddenly becomes really popular and every employer wants to use it on their projects. This is probably the biggest one that I've heard from employers, is just general lack of soft skills from new hires. So, and I know, you could make the argument that this kind of stuff comes with experience, but it really would be great to try and promote that learners spend more time thinking about skills such as research and kind of basic critical thinking and problem solving, and also working on having this constant learning mindset that you kind of need to have to succeed in this industry, because things are just always changing all the time. So who's to blame for any of these problems? Well, not really anybody, I would say. I'm not going to point the finger at anyone in particular, because, you've got all of this ideological thinking that says everything should be accessible all the time, and this should happen, and then this should happen. But actually, people just want to get a job. So it's no wonder that people go, well, all of these job adverts are saying, I need to know this framework, so I'm just going to take the quickest path I can to get employment and be able to pay my mortgage and buy food. Coding boot camps, that I've reviewed largely tend to focus on this kind of stuff, you know, and again, I'm not blaming them, I'm not saying it's a terrible thing, but they tend to be, the attitude tends to be, you know, we will take you from nothing to getting your first job in 3 months or 6 months or whatever, and that's a perfectly reasonable way to frame what you're offering to people, but there is the problem that maybe the best practices and the background skills aren't maybe being as taught as well as they could be. And of course, courses become out of date very quickly. Particularly, this tends to be a problem with university courses that I've come across. I know a lot of lecturers that really struggle to kind of keep up with all of the stuff that they've got to do, which isn't just learning about technology. They struggle to put the time in to keep their skill set current with all of the stuff that's going on in the industry. And then I'm also going to just say a few things about interview processes. And again, this definitely isn't the fault of the actual learners trying to come into the industry. But because people don't tend to have a consistent set of skills, a lot of interview processes tend to kind of be, well, we're looking for this kind of unicorn that knows these 10 things really well that are all really complicated. And all of the people that we're talking to have kind of got about 4 of these things definitely shown up on their CV. So we've got to do a whole bunch of whiteboard interviews and coding interviews and huge, long, convoluted interview processes to check whether this person can do this job that we're trying to hire for. Another interesting thing to make mention of AI, which has already been talked about today, is it fascinated me that in the last maybe 6 months to a year or so, I've started to hear multiple hiring managers talk about the fact that, oh, we had to put a load of extra processes in and the interviews have become even more complicated now because a lot of our candidates are trying to cheat using AI. I've literally heard about people having ChatGPT open in another window whilst they're doing an interview and just typing all of the interview questions into and then parroting back the answers to the interviewers. And it's like, that's a bit nightmarish. And it's difficult to really think about what to do about that. But I kind of think, well, if these people were maybe more confident in their skill sets in the first place, maybe they wouldn't have to think to rely on that quite as much. Another interesting thing is that something that we're sort of looking to do with some kind of curriculum would maybe to have some kind of industry standard benchmark certification eventually. This is kind of pie in the sky, off in the future. But maybe this certification could kind of say, you know, anybody that's got this certification, it's a trusted certification, you know, in the same way that industries such as law or architecture have trusted bodies who have these certifications that everybody gets to prove that they know what they're talking about. But we don't really have that for our industry, and employers don't really trust some random certificate from some, you know, whatever boot camp. You know, I'm not saying those boot camps are bad or not trustworthy, but employers just have a hard time trusting them. And as makes perfect sense, they value demonstrable experience and portfolios a lot more.